we present a visualisation of integrated freight modes within future port operations as part of the Transit project. A significant challenge lies in accelerating decarbonisation through the development of cyber-physical infrastructure. Given the strong societal dependence on mobility and the influence of national logistics performance indices and gross domestic product, identifying pathways that are low cost, timely, and scalable remains a complex and critical problem. This is further compounded by the complex interdependencies across the nexus of energy and transport. To date, decarbonisation efforts have focused on incremental change where these approaches fail to capture social, techno-economic, environmental decarbonisation, form multi-objective optimisations of complex systems. In this paper, we introduced the preliminary work for an interdisciplinary, user-centred design of a virtual environment centred on the integration of maritime and road freight operations at a significant economic port, the Port of Dover. We create an operational and planning decision support environment as to identify the questions, data, information, analysis, and output requirements of a digital twinning environment for key stakeholders. Developed using high-fidelity geospatial visualization, the tool integrates road freight, port operations, maritime routing, and regional energy infrastructure data within a unified three-dimensional environment. The framework enables stakeholders to develop a shared understanding of system-level trade-offs and assessment of different operational and energy constraints, which exist in the area based from current design restraints. In many ports, operational awareness remains heavily dependent on voice-based communication and two-dimensional fixed camera video feeds, which lack depth information and provide limited support for understanding dynamic traffic interactions. Therefore, integrating LiDAR sensing into port operations enables congestion reduction through real-time traffic flow insights, supporting the monitoring of near-miss events and proactive hazard prevention, delivering high-quality, reliable data under low light and adverse weather conditions, thereby significantly enhancing overall operational awareness and safety. The integration and visualization of static LiDAR point cloud data within the dashboard for a representative area of the Port of Dover, data actually collected from a similar location in Scotland. In addition, overlaid on this static data includes the results from a 2-week trial of the runtime point cloud data from a representative carriageway in Scotland and was provided by Digital Reflections Limited to feature within the port boundaries. The dataset was positioned in a representative area within the Port of Dover where the location of a static LiDAR sensor was classifying vehicle objects represented by coloured bounding boxes. This tool enables stakeholders to have an interactive dashboard to better conceptualise different decarbonisation pathways for a future port. Whilst not intended as a predictive or optimisation-driven tool, the digital twin provides a rigorous foundation for de-risking early-stage infrastructure decisions and for future integration within simulation, ontology-driven reasoning and optimisation models. A system overview is presented where design rigour has been considered from the outset, where additional anticipated layers are also included to illustrate how the dashboard has been designed to be scalable. The proposed system is implemented as a modular visualization-driven architecture powered by Cesium, an open-access software. Geospatially, the dashboard is centred at the Port of Dover, Kent, United Kingdom. The architecture integrates heterogeneous data sources spanning transport operations, infrastructure, energy systems, and maritime activity, enabling a unified and interactive digital twin representation of the port environment. The key contributions of this article are outlined. Firstly, the development of a high-fidelity geospatial digital twin of the Port of Dover that integrates road freight, port operations, maritime routing, and regional energy infrastructure within a unified 3D environment is presented. Secondly, demonstration of how immersive visualizations and interactive data interrogation can provide assurance and reduce uncertainty for diverse stakeholders in high-pressure multimodal freight systems. And thirdly, an extensible methodology foundation that supports future integration with back-end simulation, ontology-driven reasoning, and optimization models.